All right, so let's take a look at this one. Think about this one for a couple seconds before we do it. The answer is very simple. You have it. That is right. It is x to the 8th plus c, because this is 8x to the 7th, obviously. But remember, in calculus and math, nothing is isolated. We just learn a new method of parts, and it will work for any integral that it, I guess the best words is, works for. So we can, I mean, you wouldn't, but we can apply it to this. Let's do it. So to do this with parts, I'm going to pick a function that goes to 0. I'm going to pick the x cubed function that goes to 0. I'm picking it over the x to the 4th function because it will go to 0 quicker. It will give me fewer rows in my column. That leaves me with x to the 4th as my u, or I'm sorry, my dv. So I'm going to have to integrate that. And I have this x, or this 8 here. You can factor it out, but I'm not going to. I'm going to keep it with the 8x cubed because I don't want to, when you're integrating, you get all those fractions, so I just don't want that. So here we go. Plus, minus, plus. I'll add those in later because it depends on how many rows I get from this first step. First step is differentiate this until it goes down to 0. There. I'm going to add another minus in. Now I have to integrate x to the 4th. So that's x to the 5th times 1/5. Do it again, x to the 6th times 1/6. Do it again, x to the 7th times 1/7. And we should do it one more time, x to the 8th times 1/8. Here we go. So the solution to this integral is 8x cubed times x to the 5th. I always do this. I'm going to run out of space. Oh, I'm going to run out of space. So we had 8x over 5 times x to the 8th. The next is 24x squared, negative 24x squared times 1 over 30 x to the 6th. So that's 24 over 30, which is 12 over 15 x to the 8th. Next is 48x times that. So we have 48 over 210. 48 over 210 reduces to 8 over 35. So plus 8 over 35, x to the 8th again. And lastly, minus 48 over 1680. 48 over 1680, which is 1 over 35. And that's also x to the 8th. Now we have to add up all these fractions. 35 is the obvious common denominator. No, it's not the obvious common denominator. Wait, why do I have 12 over 15 here? That's my mistake. It's not really a mistake. It's not reduced. This is 4 over 5. So still, the common denominator is 35. That made it a little bit easier. Multiply these first terms by 7 over 7. We have 56. 28. add up all the numerators now because they're all common denominators. So we have 56 minus 28, which is 28, plus 8, which is 36, minus 1, which is 35. We have 35, 5, x to the 8th, which is x to the 8th plus c, which we knew going into this that we were going to get x to the 8th plus c. So the point here is not to do it with the tabular method. It's just to show you that the tabular method actually does work. So the next example, the last example, we'll use the tabular method for one that it's going to be very useful.